So welcome to this lecture. So far we have started physical work environment, and in this lecture we would cover lighting system, auditory environment and effect of noise. So as we are aware that ergonomic objective is to provide the proper environment and as well as the proper amount of light in your surrounding in order to perform any particular task. So we have to consider several lighting designing criteria. So in series with that we will learn that what are the lighting design consideration. So as far as our visual comfort is concerned, we have to consider following points. The first point is workplace should have suitable level of illumination, and balance of surface luminescence, the third point that should be considered while designing a lighting system in a workspace is avoidance of glare. The fourth point which may be considered as a temporal uniformity of lighting. So these all the points should be considered for visual comfort as well as to meet visual demands in a particular workspace. So that ergonomic objective is accomplished by designing an appropriate lighting system, one that gives sufficient but not too much light for task at hand. So there are two terms of interest which we need to understand. The first is lamp and second is luminaires. This particular lamp is obviously it may be a natural if you are working in the sunlight, or it is mostly basically a single artificial source of light. This luminaires is a complete lighting unit. It may include one or more lamps, reflectors and other piece of apparatus to distribute the light and a means to connect it to the power supply. So here we will be discussing about the lighting system first. So in that, this lamp is defined as the single artificial source of light. Example, incandescent lamp. Luminaire is a complete lighting unit which includes one or more lamps, reflectors and other apparatus to distribute the light and means to connect to the power supply. So one thing that one needs to keep in mind, that ergonomists are not any illumination engineer, but they should be able to use a light meter. So there is a light meter, there is a one, basically you can say it's a tool for ergonomic assessment in terms of checking the visual intensity. So this particular light meter is used to measure illuminance level. This light meter is used to measure illuminance levels on the work surface in, let's say, offices, shops, factories, etc., and the reading can be compared with the levels recommended in some standards. So there is some basic steps in carrying out a lighting survey for ergonomic purpose also. So another tool which is also available in order to check the lighting system or light intensity, that is luminance meter. This particular luminance meter is commercially available. So they look a little like video cameras and give the luminance of small region of any surface they are directed at. So this luminance meter is probably not necessary for basic ergonomic lighting surveys. However, this retinal adaptation often depends on luminance of objects in the visual field. So this was all about the tools that is used in this field basically, and now we need to understand as a next step is what are the types of luminaires existing. So before that I need to clarify about the lamp and the various basic types of lamp. So here I am initiating this particular topic here. एक बार ये गैप कम कर दीजिएगा, मैं स्लाइड ऐड कर रहा हूँ. So as far as definition of lamp and luminaire is concerned, it is given here, and now this lamp can be classified into two basic types. First is incandescent lamp, and second is discharge lamp. This particular incandescent lamp operate by electrically heating a filament that you in the houses. This particular incandescent lamp is frequently used. So it is basically operated by electrically heating a filament that produces radiant energy, some of which is in our visible spectrum. So the common material for this filament is tungsten, and this particular discharge lamp, it produces light by means of an electric discharge in gas. So this particular discharge lamp are generally more complicated because they require special controls to provide the conditions under which discharge is initiated and sustained. So the most common discharge lamp is fluorescent lamp. That is usually in the form of glass tube whose inner surface is coated with fluorescent material, and which contains mercury vapors whose bombardment by electrons causes light emission. So the following this category of lamp, there are several characteristics about lamp also, which is very important to know in terms of lighting design, which are going to list down those characteristics of the lamp. So here the first characteristic that a lamp should have, and that is luminous efficacy, let's say, and second is lamp life, third is color rendering, so this luminous efficacy and lamp life are economic consideration, and this color rendering is a quality feature. So the typical values of these characteristics for various types of lamps along with the common application I am trying to list out here. So if let's say the type of lamp, the luminous efficiency, lamp life, this color rendering, and typical application. So here if we use incandescent, the filament is made up of tungsten here. So its luminous efficiency basically that can be expressed as a lumen, so it could be 10 to 20. Lamp life will be if it is expressed in hours, 750 to 2000, and color rendering that is expressed as a CRI, that is 97 to 100, and it is generally for residential purpose it has been used. As far as fluorescent lamp is concerned, its luminous efficacy is 60 to 110, and its lamp life is near about 10,000 to 20,000 hour, and its color rendering is 50 to let's say 95, and it is used for commercial purposes. And high pressure mercury lamp, so its luminous efficacy is at 150 to 110, and its lamp life is 3000 to 20,000, and its color rendering is from 65 to 95, and it is used for industrial as well as for commercial purposes. So this is the characteristic of selected lamp types, and so this particular basically this luminous efficacy, this luminous efficacy refers to the efficiency of lamp. So that is its capacity to convert electrical power to luminous power. So this particular luminous efficacy is measured in lumens per watt. This particular lamp life is how long the type of lamp is expected to last, and that is expressed in hours. And there are variation and trade off within a given type. For example, long life incandescent bulb lasts longer than a conventional incandescent bulb. So, but its light output, that is in lumen, is lower during that life. And now you will be questioning about what is that color rendering which I have written here. So this particular color rendering, it is referring to the lamp's capability to illuminate object in their true colors. So in fact I am writing here as a sentence as well. That this color rendering is what? So it refers to lamps, the capability of lamp to illuminate objects in their true colors. So the lamp types vary in this capability. So the issue is important for task in which color must be identified or compared for some purpose. So for that case, the true color identification is very much important in any let's say in any workstations. So this, how would you measure this color rendering? So there is a index decided for that. So that index is CRI, that is color rendering index. So this particular CRI is most widely used measure for color rendering, and the highest color rendering index score is 100, which is obtained in daylight. So in daylight you will be able to identify the true color of any object. So in that particular case, when daylight is used for visualization purpose, then highest CRI will be 100. So as the CRI score of a given lamp type decreases, so this indicates a reduction in the lamp's color rendering capability. Unfortunately, there is somewhat of a negative correlation between CRI and luminous efficacy. An incandescent lamp gives very good color rendering, that is up to 97 to 100, but its efficacy or efficiency is very poor, as you can see from this particular table. So incandescent table will give you the true color, but its efficiency is very much low. So this is somewhat of estimation that has been done, and I have put for your knowledge. So now we need to understand what is luminaires. So this particular luminaires, as by definition we have understood, this luminaire particularly consists of one or more lamps, that is together with the other hardware component which is required to accomplish a complete lighting unit. Multiple luminaires are usually required to make a complete lighting system for a room in a facility. So modern lighting system often includes controls to alter the lighting levels depending on the time of day and function of room. So like when less artificial light may be needed, on a sunny day when there is a plenty of natural light, when let's say plenty of natural light is there through windows. So as far as the types of luminaires are concerned, so the types of luminaires may be direct lighting, indirect lighting, or combination of direct and indirect lighting. Luminaires can be classified according to the proportion of the light that are emitted above or below the fixture itself. So three major categories can be illustrated. So one of the figure that has been put for you to understand about the type of luminaires. So here you can see that the bulb is giving the light to the work area, and this is the example for direct lighting. As you see this figure, this particular example is for showing the indirect lighting phenomena. So the bulb is in this direction and its lighting direction is towards the ceiling, but still it is giving some light to the work area. So this is an example of indirect lighting, and here this particular is a combination of direct and indirect lighting. So where it is at some distance and it is illuminating the working area. So in all the cases, like direct lighting shines downward, providing high direct illumination of the work area, and however glare may be a problem. Indirect lighting shines on the ceiling here, because the ceiling is usually a color with high reflectance, so the most of the light is reflected downward and diffused to reduce glare. So in this way these things have been covered. So as a summary of what we have learned in previous slides, so there are two basic types of lamps: incandescent lamp and discharge lamp. So now the another topic that we are going to cover, that is auditory environment and the effect of auditory environment to the system performance, which is very much essential as far as ergonomic area is concerned. So the auditory environment and noise, so in that this particular auditory is the second most important means by which human receive information. So as we know and we are aware of the fact that visual and auditory stimuli both in a combination gives the 95% or more of a person's information input, and this auditory environment also includes noise, which is defined as the unwanted sound. So this particular auditory stimuli, we can say, is the second most important means by which we perceive the information. And so apart from this understanding of this noise and auditory stimuli, so we will now try to understand what are the possible effect of noise on humans. So now effect of noise we will try to understand. So the possible effects of noise on human being are both physiological and psychological. So the effect may include the distraction from work which you are doing from let us say prolonged period of time. So sudden noise level increment will give you the distraction and deviation from your work. Negative emotions such as annoyance, frustration, anger and fear. Interference with conversation, thinking and other cognitive process. Interference with sleeping, temporary hearing loss and permanent hearing loss. So these are the possible adverse effects if the noise level exceeds the permissible limit of a workspace where or a workstation where you are performing your task. So as far as noise factors that affect human, so there are basically in the sound, noise is basically a sound which is unwanted for a human being. So sound is characterized by two attributes, that is frequency and its pitch. So the physical attributes of sound is that frequency which is perceived by the listener as pitch and intensity, and which is perceived as a loudness. So the noise is characterized by same attribute. In assessing the potentially negative effects of noise on human performance, intensity is more important of two. So human performance is directly related to sound intensity. Like it is not directly related, it is not in the sense of directly proportional, but it is in relation with intensity of the sound. So industrial noise is usually broadband. So as far as industrial noise is concerned, so is broadband, the meaning of which is it is composed of wide range of frequencies. So the importance of frequency is reduced. So in addition to this intensity, the elapsed time of exposure to the noise is also important. So increased duration of exposure to loud noise increases the risk of hearing damage. Thus we have two factors that are of primary concern in assessing the effect of the noise on the human worker. So the first is intensity of noise, that we need to take care, and second is duration of exposure to the noise source. In fact, that intensity and duration of exposure both can be measured with the equipment that has been developed. So in case of continuous noise of constant intensity, so duration is simply a time measurement. So this particular sound intensity is measured by using sound level meter. which is basically a sound pressure meter that converts the reading to decibels. So most meters are equipped to allow the user to set one of the several different scales when taking a sound pressure measurement. So the two most important scales are designated as A and C by the American National Standard Institute, that is ANSI. There is an association. So difference between these A and C is that they electronically weight certain frequencies of sound pressure signal differently. So the A scale is weighted to approximate the hearing response of human ear, and for this reason it is the most commonly used scale, and one used by OSHA, that is Occupational Safety and Health Act. So in fact health agencies, and just to establish noise level standards. So decibel unit for A scale, in fact I am writing here, decibel unit for A scale is dBA, and for the C scale intended to weight all frequencies the same. So in this way I think the sufficient minutes have been spent in order to understand the effect of noise on human being and the factors and the effects. So I am closing this lecture right now, and just for refreshing purpose I have added one fact, that if you are right-handed you will tend to chew your food on your right side, and if you are left-handed you will tend to chew your food on your left side. And again, as an engineer, suppose if you were working for noise control, which types of solutions you would implement to reduce the adverse effect of noise on the workers working in an industry. Think about that, try to find out the solution, possible ways in order to reduce the noise level, and there is a graffiti for you. Enjoy it, and till I start at the next topic. Thank you very much for your patient hearing.